Welcome to Sundar's lecture. This is lecture number 56, and in this lecture we are going to take some numerical problems related to maximum power transfer theorem, and before that we try to get what is the expression for maximum power. So see, this is the equivalent network, right? This is point A and point B, and we know these kind of things already. So between these 2 points we will have VOC or VTH, and then we will have Thevenin's resistance. And now we know the current through this circuit is I, and what is the power in the load, that is I square into RL, and what is I? I will be is equal to VOC divided by RTH plus RL. So if you substitute in this equation, you will get power will be is equal to VOC square divided by RTH plus RL the whole square into RL. So that is the power expression. And one thing, what is the condition? Condition for maximum power transfer? Condition for Pmax, we know, right? RL should be is equal to RTH. So we have studied this one. We have derived this one already. And now, if you want to get what is the maximum power, then you substitute in this equation. See, if you want to get what is Pmax, then what you can do? VOC square into RL divided by, I am just going to change this RTH to RL. This will be RL plus RL the whole square, right? So now if I further simplify this, what I will get? See, VOC square into RL divided by, this will be 2 RL the whole square. Maybe I will directly write it down, 2 RL the whole square, and that will be comes out to be 4 RL square. And if you cancel this RL and this RL, and finally you will get Pmax should be is equal to VOC square divided by RL or 4 RL, or you can write, or you can replace this RL with what? RTH, right? Both are same, right? Or you can write it as Pmax should be is equal to VOC square divided by 4 RTH. So this is the expression. For maximum power transfer in any circuit. Maybe even it is applicable for AC circuit too. Why? Because we are going to find what is the maximum power transfer with for the real power. So it will be RTH. So RL, it should be considered to be RL. So this is the condition for maximum power in an circuit, in an electric circuit. Right? So we will take a problem now. See, this is the problem. Find the load impedance required to be connected across terminal A and B between these 2 points for maximum power transfer in the network shown. Also find Pmax in the load. See, we need to find a resistor or maybe impedance. This is AC circuit, so we have to find the impedance value so that the power in the circuit should be transferred maximum to this load resistance or load impedance. We need to find that load impedance, right? So what is the thing you need to find? You have to find what is the ZL. Yeah, that has to be connected here. Maybe across point A and B, you should find what is the ZL. Maybe this is ZL, and I can write it as this is RL. This can be JXL. I need to find this one. And what is the formula? We need to see, this is the maximum power, right? So to transfer maximum power, what should be the ZL? ZL should be ZTH star, or you can write it as RTH minus JXTH. Right? Can you understand? So this is the thing you need to find. And for this you need to find what is the ZTH value. And if you know what is ZTH, you can get what is the ZL value, right? So to find ZTH, ZTH. What you need to do, you have to short circuit this voltage source and then you need to find what is the equivalent impedance across point A and B. So that is the thing, right? So we will see, now I have drawn this circuit. See, I have short circuited the voltage source. And now what we can do, see these two impedances, maybe this is the value of X, total X. If you want to find what is the total X, then this total X will be what? This total X will be 10 ohms, right? J10 ohms, J10 ohms. And what is the R here? This R will be is equal to 10 ohms. And you see, these two are connected in parallel. And what is the equivalent resistance? If you want to find, ZTH should be is equal to, if it is connected in parallel, then 10 into J10 ohms divided by 10 plus J10 ohms, right? This is the expression you need, right? You have to add in the denominator and you have to multiply in the numerator. Those two resistor values, if they are connected in parallel, and we know these kind of basics already, right? So if you simplify this, you will get ZTH will be is equal to 5 plus J5 ohms. 5 plus J5 ohms. So this I have written this expression in the rectangular form, or you maybe get you will get this expression as, maybe if you find it out, you will get ZTH is equal to 707 at an angle of 45 degree, at an angle of 45 degree ohms. This is the expression, we have written it in the polar form, right? But we need only the rectangular form, since we know that ZL should be is equal to RTH minus JXTH. See, this is the value of RTH and this is the value of XTH. And what should be the ZL now? So ZL should be is equal to 5 minus J5 ohms. 5 minus J5 ohms. So this is the condition for maximum power transfer, right? For P max, you have to connect this resistor, this impedance across the point A and B. And what is the question they have asked? Also to find the P max in the load. So what is the formula? What is the formula? We know that P max we have seen now, that is equal to VOC square divided by 4 RTH. That is the thing you need to find. And what is the thing you need here? We need what is VOC, right? So what you need to do, you have to find what is the open circuit voltage across these 2 points. And that open circuit voltage can be substituted in this expression. So to find open circuit voltage, we just redraw this diagram again. See, I have drawn the diagram. So you have to find what is the open circuit voltage across these 2 points. So what I can do, I can find what is current here, because I have only one loop. Right? So I am just writing it as I. So if you want to apply the KVL, so if you apply KVL, what you will get? This value will be 10 minus 10I, and then you will get these two. What is these two? And if you simplify this, you will get J10, right? So that expression will be also 10JI, that should be is equal to 0. And if you simplify this, you will get 10I plus 10JI should be is equal to 10. And if you further simplify this, if you take I commonly outside, so you will get 10 divided by 10 plus J10. Right? This is the final expression for I. So if you simplify this, then you will get I should be is equal to, and you will get 7.07 at an angle of minus 45 degree amperes. So this is the current here. See, this is the current here, and the current flow in this resistor will be what? I can write it as 7.07 at an angle of 45 degree, right? Or you can convert this into rectangular form. That is also possible, right? So if you want to find what is the voltage between these 2 points, start from this point, go in this way and come here, and you reach this point, then that will be your VAB, right? That will be your VAB. So we will do that. So what is V? See, from here I will take. So from this point it will be plus 10. So if you want to find what is VAB, or you can consider it to be VOC, and if you go for this one, this is plus 10 because I am going from minus to plus, and I am going in the same direction as the current flow, so I have to put minus 7.707 at an angle of 45 degree into, what is this value? What is this value? 10 into 10, right? Into 10. That's all. We have reached to point A. So if you simplify this value, then obviously you will get VOC should be is equal to 7.07 at an angle of 45 degree volt. At an angle of 45 degree volt. So we have found what is the VOC now. So you just substitute this VOC in this Pmax expression now. So what you will get? So Pmax should be is equal to 7.07 at an angle of 45 degree, the whole square, VOC square divided by 4 into RTH. What is RTH? What is the value of RTH? It is 5. Right? It is 5, right? 4 into 5. So this is the Pmax expression. Right? If you are going for absolute values, what you can do, you just take this 7.07, only absolute value, right? So it will be very simple, right? So you don't take this values, maybe you take 7.07 because we are going to get what is the absolute value or real power value of the Pmax. So if you substitute in this expression, you will get this one. I have just taken the absolute value. So if you find this one, so Pmax should be is equal to 2.5 watts. See, what is the question asked to us? We have to find what is the resistor or impedance connected between point A and B, so that the maximum power that can be transferred through this impedance, and we know that ZL should be RTH minus JXTH. This one we have already seen. To transfer maximum power, your load impedance should be the complex conjugate of the Thevenin's impedance or equivalent impedance in the circuit. And we have found what is the ZTH, and we have written what is ZL, and then we have gone for the Pmax expression, and we need what is VOC. We have found the I, and then we have found what is the value of VAB or VOC, and then we have substituted in this expression to get the maximum power. So this is how you need to find the maximum power and what is the load resistance that can be connected across point A, B to get the maximum power. So this is the AC circuit problem, right? This is an AC circuit problem. So we will take a DC circuit problem now. See, here the question is, for the circuit, find the value of R that will receive maximum power. We need to find what is the value of R. Determine this maximum power also. The same question. Whatever the question they have asked you in the AC circuit, the same question they have asked you here. So now we need to find what is this R, which means this is the load resistance. Maybe you take for our understanding, this is point A and this is point B, and let it be RL for us. We will consider it to be RL because we always do that, right? So we need to find what is the RL, and what is the RL to transfer maximum power. That should be is equal to RTH. We know that should be is equal to RTH. For Pmax, that is the question, right? To find maximum, to find the value of R for the maximum power. So what should be RL? It should be RTH, right? So we have to find what is the value of RTH. And what is the other question? Determine the maximum power. What is the maximum power formula? We know, right? What is Pmax? Pmax should be is equal to VOC square divided by 4RTH, right? So this is the maximum power, and we need to find what is the value of VOC, right? And also we need to find what is the value of RTH. So for both cases, you need to find what is the value of RTH. So to find, so our first we will go for VOC square, VOC to find VOC, or we can say it as VTH, right? So if you want to find what is the value of VTH, then what you need to know, you should know what is the, for example, if you are going from this point to here, to this point. So you need what is the current flow in this resistor, also in this resistor. So for that I am going to choose this as I1 and maybe this as I2, right? I'm just doing because only two loops are available. So if you simplify this, you will get obviously what is the value of I1 and I2. So go for matrix method. It is very simple, right? So what is the value of this one? Okay. If you are going for mesh current analysis method, how many loops are available here? How many loops are available? Only two loops. So if you are going for two loops problem, this will be R11. What is the R11? It will be 12.3. And what is R12? Between these 2 points there are no resistance connected, so it will be 0 and again it will be 0. And if you go for R22, what is the total resistance? It will be 29 point, so it will be 30.5, right? So these two resistance are connected and we know that this is I1 and I2. We need to get these two values and that should be is equal to what? V1. What is V1? See, I am going from minus to plus, so it will be plus 100 volt. And you see in this one also I'm just going in this direction. And what is that one? That is minus 2 plus, right? From minus 2 plus I am just considering. So this one will be also 100. So if I get what is the expression, then it will be 12.3 maybe. Okay, 12.3 I1, 12.3 I1 and it is 0. That should be is equal to 100. And if you are going for this expression, maybe these two are positive because these two are diagonal elements, and this is 0, then that will be 30.5 into I2. That should be also is equal to 100. And if you simplify this, so if you simplify, what you will get? I1 should be is equal to 8.13 amps and I2 will be is equal to 3.28 amps. See the current flowing in this test. So this resistor is only connected in first loop. So what is the value? It will be 8.13 amperes. And this resistor 19.6 ohms as connected only in the loop 2. So the current flow will be in this direction, right? So both are positive. So assume the current directions are correct. These are all basic things. So this will be the value. So if you are going for VAB, what you will get? You have to travel in this direction. You can write it as VAB or VTH, or you can write it as VOC, anything it may be, or everything is a correct answer. So if you are going from this point, I am going in this way. See, I am going opposite to this resistor, opposite to this current direction. So I will get 19.6 into 3.28. So then I am going in the same direction as this current. So this will be minus 7.1 into 8.13. And if I simplify this, so VOC should be is equal to 6.565 volt. Or maybe VTH. I'm not going to write it down anyhow. So this is the value of VOC. We have found what is VOC, right? So we have found what is VOC. Then what you need to do? You need to find what is the value of RTH. See, if you want to get what is the value of RTH, see, to find RTH, you need to short circuit the voltage source. Right? We have short circuited this one, and we need to find what is the resistance between these 2 points. See how these two resistors are connected, these 2 points are connected, and also these 2 points are connected. So these two resistors are connected in parallel. And see, these two resistors, both ends are connected, and again these two are connected in parallel, and between these two parallel connections there is a connection. That is what I have drawn here. I have just redrawn this circuit here. And you see, these two resistors are connected in parallel, these two are connected in parallel, and these two parallel combinations are connected in series now. Right? So it is very simple to simplify this resistor bunch. So now what we can do, these two are connected in parallel, right? So if you want to find what is the value of RTH, then 5.2 into 7.1 divided by 5.2 plus 7.1 plus, because these two bunches are connected in series, right? So this will be and 10.9 into 19.6 divided by 10.9 plus 19.6. And if you simplify this one, RTH should be is equal to, I am just getting it to be 10 ohms. 10 ohms. You just simplify this one by yourself. Obviously, you will get what is the value of RTH. It is 10 ohms. So now what we have done, we have found what is RTH and what is the value of VOC. So if P should be maximum, what is this load resistance R? That should be is equal to RTH. What is the value of RTH? So for P max, the value of R should be is equal to 10 ohms. That is the first question. And you need to find what is P max, right? So to find P max, VOC square, what is the value of VOC? 6.565. So this value 6.565 the whole square divided by 4 into RTH, that is 10 ohms. So if you simplify this, you will get P max will be is equal to 1.077 watts. This is the second question. So see, we have found what is the value of resistor, what is the value of R? R should be is equal to 10 ohms, and then we have found what is the maximum power. What is the maximum power? Maximum power should be is equal to 1.077 watts. So see, try to understand one thing. If you are asked to find what is the value of load resistance R, so that maximum power will be transferred in the circuit or in the load resistance, then what you need to do, you just try to find what is the value of RTH in the circuit, and that resistor should be connected in the load so that maximum power can be transferred. That is the first thing. And if you are asked to find what is the value of power that can be transferred at a maximum level, if that question is asked, then you need to use the formula VOC square divided by 4 RTH. And you know what is RTH? You just try to find what is the value of VOC by open circuiting the load resistance, and you need to find what is the value between point A and point B. So this is how you need to tackle the maximum power transfer theorem, right? So with this, we will wind up this class, and in the next class, we will take up a new topic or a new theorem in the next class. You go through this, you will get an idea. Thank you.